Hello student, good morning. I am Dr.A.K, Professor of Chemistry. Today I am going to discuss heterogeneous equilibria. Last class I have discussed homogeneous equilibria in gaseous state. Now I am going to discuss heterogeneous equilibria, and after heterogeneous equilibria I will discuss some important numericals. Then what is a heterogeneous equilibria? That I am telling you. Equilibrium in a system having more than one phase is called heterogeneous equilibrium. More than one phase. Equilibrium in a system having more than one phase is called heterogeneous equilibrium. The equilibrium between water vapor and liquid water in a closed container is an example of heterogeneous equilibrium, and we can represent it like a H2O liquid, sign of reversibility. H2O gas means H2O liquid, and sign of equilibrium H2O gas, liquid and gas. Then reactant is in liquid state and product is in a gaseous state. Then this is the example of heterogeneous equilibria. In this example means H2O liquid and H2O gas. In this example there is a gas phase and a liquid phase. Okay, H2O product gas and H2O liquid, that is the, you can say, liquid phase. One is in liquid phase, other is in a gaseous phase. Hence this is the example of heterogeneous equilibria. In the same way, equilibrium between a solid and its saturated solution. Solid and saturated solution. Suppose you have water. In that water you have added one solid like calcium hydroxide. Suppose calcium hydroxide is solid, and calcium hydroxide actually is a solid. If you dissolve in water means aqueous. Okay, solution, aqueous solution AQ means solid you have dissolved in water, then it forms solution. Then that is called aqueous solution, AQ, a small small q, aqueous solution. Then now if you will add calcium hydroxide, solid calcium hydroxide in water, then it will form solution. Then what will happen, that suppose you have added little more solid in that, then there will be equilibrium between calcium hydroxide solid and water, means solution and solid, which is dissolved means it forms the solution. Then and excess solid, then this solid and this solution, aqueous solution, both will be in equilibrium. And in solution what you will find, calcium ion will be there, Ca2 plus. In solution calcium ion will be there, and what will be there, hydroxyl ion also will be there, OH minus. Then both are present in solution. Calcium ion is also present in solution and OH ion is also present in solution. And in that solution solid is also there, calcium hydroxide solid is also there. And because some solid dissolved in water, then it forms solution. Then in that solution calcium ion will be there, Ca2 plus, and OH1 minus will be there. Then you can write in the equation form COOH whole 2, that is a solid. In bracket you can write S means solid plus aqueous means water, AQ. Then it will dissolve, this calcium hydroxide will dissolve in water, and in solution it will form calcium ion Ca2 plus aqueous. It is because it is in water dissolved, that's why Ca2 plus aqueous. In bracket AQ you can write means aqueous, calcium is dissolved in water, aqueous, plus 2OH, aqueous. Okay, in solution, calcium hydroxide will be in the form of calcium ions, aqueous, plus 2OH minus aqueous. Then now here you can see that this example is also heterogeneous. How? Then because it is in a solid form also and aqueous form also. Solid form, reactant is in a solid form because the calcium hydroxide, solid calcium hydroxide you have dissolved in water. Then solid is also there, and in solution calcium ion is also there, OH ion is also there, aqueous solution. Hence this equation has two phase, solid and aqueous. Hence this is the example of heterogeneous equilibria. Then this I told you, second example of you can say heterogeneous equilibrium. Heterogeneous equilibrium often involve pure solids or liquids. Here you have to understand, heterogeneous equilibrium or heterogeneous equilibria often involve pure solids. Solid means pure solid only, or liquids. Okay, we can simplify equilibrium expression for the heterogeneous equilibria involving a pure liquid or pure solid as the molar concentration of pure solid or liquid. Okay, and it should be constant. Here we can simplify equilibrium expressions for the heterogeneous equilibria involving a pure liquids or pure solid as the molar concentration of pure solid or pure liquid. Okay, and this value will be constant. It is constant, means independent of the amount present in the solution. Independent of the amount present in the solution. And in general way we can write, in other words we can tell, if a substance X, capital X, is involved, then X solid, S small solid you can write as a S, X solid and X liquid. Okay, because some solid will dissolve in water or liquid. That's why same things you can tell X solid and X liquid are constant. Okay, both are present. Then they are not depending upon the amount, how much. Okay, but it should be. It must be there. These things, solid and liquid must be there. Liquid or gas must be there. Two phase should be there, either in reactant form or product form. It should be there. It must be there. But how much amount is there? That is, it is independent of that. Then in general way you can tell substance is X, then X solid, and that substance, because it is dissolved in water, then we can write X liquid also. In bracket we can write a small l. Okay, or in bracket we can write a small s for solid, L for liquid. Then these are constant. Means here pure solid is constant, pure liquid is constant. Okay, this you have to understand. Pure solid is constant, pure liquid is constant. Okay, and it is not mentioned in the expression. Expression you will write for Kc or Kp. Kp is for gas, forget, all will be in the gaseous part. Kc expression you will write. Then in that expression, which is a pure form, that is not written there. One should not write. Even you are writing in final equation, it should not come, because that is the constant, and for constant its value will be considered as unit, means 1. Okay, this is the important things I told you. Whatever the amount of x is taken, okay, but that amount has no value, means it is important of independent of x. Okay, and another things, these things, another example you can tell, third example, calcium carbonate. Then thermal decomposition of calcium carbonate, which is an interesting important example of heterogeneous chemical equilibrium. Then calcium carbonate is there, solid, in bracket you can write S. Okay, solid calcium carbonate. When you will heat it, means then decomposition will start, it will break. Then product you will find calcium oxide solid you will get, plus carbon dioxide gas you will get. Two things you will get as a product. Calcium oxide means a CaO solid, plus carbon dioxide gas. Then in equilibrium way you can write, in equation you can write calcium carbonate, sign of you can say equilibrium, and after that you can write two product, calcium oxide solid plus carbon dioxide gas. This is the equation you can write in this way, reaction. Now what is the Kc value? Kc value for this reaction means calcium carbonate solid, and it is giving two product, calcium oxide plus carbon dioxide. Then what will be the Kc? Then Kc is equal to, you have to write the, you can say first products upside you write concentration of products of calcium oxide into carbon dioxide. Okay, you will write upside, and down what you will write, calcium carbonate solid. Then upside you have written calcium oxide solid into, you can say, concentration of carbon dioxide gas. Then here you can see, here left side means reactant is solid, and product one solid and one gas. One solid and one gas. Then now here you can see, on the basis of, you can say, a stoichiometric equation, what we have written, I told you, okay, reaction, you have written the Kc value. Then here calcium carbonate is solid, and it is in a pure form. Calcium oxide is also solid in pure form. Both are solid. That's why both are in pure form. That's why both are constant. Then out of three, two are constant. Means calcium oxide, which you have written upside, that is the constant, and down calcium carbonate you have written, both are constant. Then only upside carbon dioxide gas is remaining. Okay, only that you have to consider. This constant value you have to not consider. Then Kc is equal to, you can write, means finally Kc equation, Kc will be, you can say, sign of, you can write equilibrium sign, then carbon dioxide gas, only molar concentration of carbon dioxide. Okay, since calcium carbonate solid and calcium oxide solid are both constant, therefore modified equilibrium constant for the thermal decomposition of calcium carbonate will be, that was the Kc, because these are the constant. Then new constant value K dash C you can tell. K dash C, that is equal to only more carbon dioxide, molar concentration of CO2. That is the modified, because they are constant, means some value they may have. Hence new constant K dash C you can tell, that will be molar, that will be, you can say K dash C equal to, or you can say sign of equilibrium you can write, then Kc sign of equilibrium you can write. That depends only upon carbon dioxide, CO2, means K dash C new equilibrium will be equal to molar concentration of CO2 gas. You have to not mention calcium oxide and calcium carbonate, you have to not mention. Only carbon dioxide you have to mention. Hence new equilibrium means K dash C, that is equal to molar concentration of carbon dioxide. Here equal to means sign of equilibrium. Then here also, because carbon dioxide is gas, hence this equilibrium constant Kc or K new equilibrium constant K dash C, what you have written, that also you can write Kp, because it is a gas, carbon dioxide is gas, hence you can also write Kp, that is the Kp is equal to pressure of carbon dioxide, in both way you can write, in the concentration form also and in Kp form also, means Kc is equal to only concentration of carbon dioxide and Kp is equal to pressure of carbon dioxide. This is the correct way to write the, you can say, Kc and Kp value for decomposition of calcium carbonate. Okay, decomposition of calcium carbonate reaction, this is the only carbon dioxide you have to mention. Then Kc in the form of Kc also you can write, in the form of Kp also you can write. Next example I am telling you, that is the, you can say, these things, nickel plus carbon monoxide, nickel plus carbon monoxide, you can say, we can take another example. Okay, then here nickel is a solid, Ni, nickel is a solid. Near the nickel you write in a small letter S, means solid. Okay, in bracket, in a small bracket you can write solid, plus carbon monoxide CO, 4CO, that is the gas, in bracket you write a small g, gas, and sign of equilibrium you write, and then you write product, main product is only one product, nickel tetracarbonyl, NiCO whole 4, NiCO whole 4, nickel tetracarbonyl, this is the gas, Then here again you see, in the reactant side, one solid is there and one gas is there, means nickel solid, carbon monoxide gas, and the product side again gas, nickel tetracarbonyl is gas, NiCO whole 4. Okay, then this is the balanced equation, Ni plus 4CO, that is equal to NiCO whole 4. Then here again it is heterogeneous, because here out of three reactant, out of three you can say substances, one is solid, other two are gas. That's why it is also you can say out of three, two are gaseous phase, one is solid phase, and it is also heterogeneous reaction. Then now for this also, how will you write the Kc value, Kc expression? Then Kc expression is equal to, now you can write, first you write product upside and down you write, you can say, reactants. Then product is a nickel tetracarbonyl, in big bracket write NiCO whole 4, because Kc when you are writing, then more for the molar concentration you have to write big bracket. Okay, big bracket you have to write, and for Kp a small bracket, but here in Kc big bracket you have to write. Then molar concentration means big bracket, and inside the big bracket you have written nickel tetracarbonyl NiCO4 divided by, only here you have to write CO power 4, because 4 CO was there in reactant side, 4 CO. That's why CO you write in big bracket and power 4. Okay, but don't write Ni solid. In reactant solid is there, but here you have to not mention that nickel. Okay, it must be remembered that for the existence of heterogeneous equilibrium, pure solids or liquids must also be present, however small the amount, but it must be there at equilibrium. But their concentration or partial pressure do not appear in the expression of the equilibrium constant in the reaction. Okay, and next example I am giving you, that is of, you can say, silver oxide plus nitric acid. Silver oxide Ag2O, that is a solid, in bracket you write solid, plus HNO3, nitric acid aqueous, AQ write, nitric acid aqueous. All acids are aqueous, HCl, HNO3, H2SO4, H3PO4, all are aqueous. Aqueous is water, because gas is dissolved in water, then acid is formed. Okay, because gases generally they are dissolved, gases are dissolved in water. When it is dissolved in water, only acid will form. That's why it is written aqueous. Then this equation you can write Ag2O plus 2HNO3, that is equal to 2AgNO3, means silver nitrate aqueous plus H2O. H2O is in liquid form, L you can write, liquid. Okay, pure liquid. Okay, H2O liquid. Then here you can see in this reaction, reactant side Ag2O, that is the solid, plus 2HNO3 aqueous is there, and product side silver nitrate aqueous is there, plus H2O liquid is there. Then Kc value, how will you write here? Then here you have to write products. Then product side silver nitrate aqueous is there, that you have to write. 2 moles of silver nitrate is there, 2 mole of silver nitrate, means under the big bracket you write AgNO3 power 2, and divided by, means divided by, you have to write reactant. The reactant you have to write only nitric acid, HNO3 power 2, HNO3 power 2. You have to not write two things. Silver oxide, which is solid, you have to not mention here. Along with the reactant, silver oxide you have to not mention, because it is a solid, pure solid. And product side, water is there, H2O liquid, that is a pure liquid. That's why for pure solid, pure liquid, you have to not mention. Then reactant side only silver nitrate you have to mention, that is the AgNO3 power 2, because 2 AgNO3 is there. And reactant side you have to write HNO3 power 2, because 2 HNO3 was there in balanced equation. Then Kc is equal to silver nitrate power 2 divided by HNO3 power 2. Then this 4 example I have given you for heterogeneous equilibria along with Kc expression. Okay, and here again one more important things you have to understand. Unit of equilibrium constant. What will be the unit of equilibrium constant. Then here in a very simple way, you understand here that Kp or Kc value has no unit, only number will be there. Only number will be there. As for example, in the decomposition of calcium carbonate, Kp value was 2 into 10 to the power 5 Pascal. But here it will be comparative. 10 to the power, you have 10 to the 2 into 10 to the power, but in comparison to 10 to the power 5 only, it is there only 2. Pascal will cancel out. 10 to the power 5 Pascal divided by 10 to the power 5 Pascal, because it is a comparative, relative, hence both unit will cancel, then only 2 will remain. Then it has Kp or Kc value have only number, no unit, just like no, you can't write mole, you can't write liter, you can't write kg, no, only number. Maybe 1.3 into 10 to the power 5, 1.0 into 10 to the power 3, 1.357 into 10 to the power 5, like that way, no unit, only number. Okay, this I told about the, you can say, the heterogeneous equilibria, examples, expression and unit I have told you. Now I am just going to discuss these things, numericals. Numericals I am going to discuss with question. Okay, I will explain it. I will read the question and then I will explain how to solve the numericals. Because in examination from this chapter, many numericals are asked. Then now I am reading the question. Then first question I am reading. I am reading the question now. The following concentrations were obtained for the formation of NH3 from N2 and H2 at equilibrium at 500 Kelvin. N2 molar concentration of N2 is equal to 1.5 into 10 to the power minus 2 m and H2 is equal to 3.0 into 10 to the power minus 2 m, and NH3 concentration, molar concentration of NH3 is equal to 1.2 into 10 to the power minus 2 m. Means concentration of H2, N2 and HI they have given. Now concentration of H2, N2 nitrogen and ammonia is given. Okay. Then you have to calculate equilibrium constant. You have to calculate equilibrium constant, Kc value or Kp value, but here they have given concentration in a molar form. Then you have to calculate only Kc. How will you understand that you have to consider Kp or Kc? Then if data is given in terms of molarity, capital M, then you calculate Kc. If all things are given pressure, if all concentration they are given in the term of pressure, then you calculate Kp. This I have told you. I am telling you very important things. If concentration they are giving in molarity, then you calculate in the term of Kc. If they have given all, means concentration in terms of pressure, then you can calculate in Kp form. Then now Kc you have to consider, then it is very easy to calculate the Kc value. First you write the expression. N2 plus 3H2 that is equal to 2NH3. Here you have to write sign of equilibrium, not equal sign. I am telling just to make it easy. Then N2 plus 3H2, that is equal to 2NH3. This is the balanced equation you have to write. Then what is the expression for Kc for this equation? Then Kc is equal to what you will write? Product is 2NH3, means molar concentration of NH3 power 2 divided by molar concentration of N2 into molar concentration of H2 power 3. Then now all value they have given. Molar concentration of ammonia they have given, molar concentration of N2 they have given, molar concentration of H2 they have given. Then all value you put and simplify it, you will get the result. Very easy. As for example, now in NH3 they have given 1.2 into 10 to the power minus 2 m. They have given. Then 1 point, right there for NH3 you write 1.2 into 10 to the power minus 2 power 2. And for nitrogen they have given 1.5 into 10 to the power minus 2. Then you write this value. And then for hydrogen they have given, it is given 3.0 into 10 to the power minus 2 power 3. Then just to simplify it, simplification you know, multiplication, multiplication, division, all things, addition, subtraction, all things you are knowing. Then just to simplify this, after putting the value, then you will get the result, you will get 1.06 into 10 to the power 3 you will get. That is the Kc value. See, at Kc value you have written, no unit is there, because obviously all thing will cancelled. Mm value is there, now then all value will be cancelled. As for example, here m value, all they have given the term of m. All value they have given in the term of m. Then here what will happen, that obviously because you are always, it is a relative value. Relative, whatever m value will come, that divide by m. Obviously mm will be cancelled, bar will be cancelled. Okay, hence no unit will remain, only number will remain. Hence Kc value for this reaction is 1.06 into 10 to the power 3. This is the answer. Okay, then very easy numericals. Very easy numericals. Only you have to put the value and get the result. After solving the, after making solving it, you will get the result. Now second example, second problem I am telling you, second numericals. Okay, this is also easy. At equilibrium, the concentration of N2 that is 3.0 into 10 to the power minus 3 m. Oxygen means O2 value is 4.2 into 10 to the power minus 3 m. And NO, nitric oxide, its value is given 2.8 into 10 to the power minus 3 m. In a sealed vessel at 500 K. At 500 K, these gases were in equilibrium. Means at equilibrium they have given the value of nitrogen and NO value they have given at equilibrium. Okay, nitrogen, oxygen, NO value has given. These were taken in a sealed vessel. And you have to calculate, this was at 500 Kelvin. Temperature was maintained 500 Kelvin, and you can say you have to calculate what will be the Kc for this reaction. Again I am reading the question. At equilibrium, the concentration of N2 is equal to 3.0 into 10 to the power minus 3 m. Oxygen means O2, that is equal to 4.2 into 10 to the power minus 3 m, and NO is equal to 2.8 into 10 to the power minus 3 m in a sealed vessel at 500 K. What will be Kc for the reaction? Reaction is N2 plus O2, that is equal to 2NO. All are in gaseous state. N2 gas plus O2 gas, and product is 2NO gas. Then what will be the Kc value? You have to calculate. See, all are in gas. You will think to calculate Kp, but you can't calculate Kp because value they have given in molarity m. That's why you have to consider, you have to calculate Kc, not the Kp. Okay. But one thing is there, relation is there. If you are knowing the Kc value, Kp value calculate, because Kp is equal to Kc RT and power delta n. Then you can calculate Kp also. But what question is asking, answer accordingly. Here they are not asking to calculate Kp, but you can calculate, because Kc value you will come to know. Then relation you are knowing, Kp is equal to Kc into RT power delta n. Delta n is equal to what? Number of moles of you can say product minus reactant. There you can see how we will calculate the Kc in present question. Now here it is also very easy to calculate, because NO concentration is given, N2 concentration is given, O2 concentration is given. Then Kc expression will be, you know how to write the Kc expression. Kc will be product is NO, 2NO, then NO power 2 divided by reactants. Two reactants are there, N2 and O2, 1 each. Then down you can write into molar concentration of N2 into molar concentration of O2. And now all values are given. You write the value. For NO it is 2.8 into 10 to the power minus 3 m. You have written power 2 divided by N2 is 3.0 into 10 to the power minus 3 m. And for oxygen O2 it is given 4.2 into 10 to the power minus 3 m. After putting the value, you have written the value. Now just solve it. Then finally you will get 0.622. Final value will be 0.622. Okay, no unit, only a number, 0.622. This is the Kc value. Then see how easily you have calculated Kc value. Now third problem I am telling you. Third problem I am reading now. Problem third. PCl5, PCl3 and Cl2 are at equilibrium at 500 K and having concentration 1.59 m PCl3, 1.59 m Cl2 and 1.41 m PCl5. Means they have given concentration for all three. Means for PCl5 1.41 m, and for PCl3 1.59 m, and Cl2 also same value 1.59 m. Okay, then this value they have given. You have to calculate Kc for the reaction. Means reaction is given PCl5. Means this is a dissociation of phosphorus pentachloride, PCl5. That is giving two product, PCl3 plus Cl2. PCl3 plus Cl2. This is the reaction. PCl5 is giving two product, PCl3 plus Cl2 after decomposition. You have to calculate Kc value. Kc value. Then now again very easily you can solve this problem, because Kc is equal to, now you can write the expression for Kc. Then Kc is equal to molar concentration of PCl5 into molar concentration of Cl2 divided by molar concentration of PCl5, as usual what you have written in the same way. And after that PCl5 and Cl2 concentrations are given. PCl3 concentration is 1.59 and Cl2 also same 1.59, means 1.59 square you can write, divided by PCl5 concentration is 1.41. Then after solving you will get the result like 1.79. This is the Kc value, means Kc is equal to 1.79. See how you can say easily you have calculated. Now can say next problem I am telling you, this is little different. This is little different, and because it is a little not tough, if you will understand it will be very easy also. It is also easy. I will explain. Then this type of question what I will discuss now is asked in all competitive examination and even in a board university exam also. Then now question I am reading. The value of Kc, the value of Kc is equal to 4.24 at 800 Kelvin for the reaction. Okay, reaction they have given carbon monoxide plus H2O, and product it is two products it is giving, carbon dioxide plus hydrogen. Then this is given in the question. Okay, carbon monoxide gas plus H2O vapor means gas, these are the reactant, and now it is giving product carbon dioxide gas plus H2 gas, and its Kc value has been given 4.24 at 800 Kelvin. Okay, calculate equilibrium concentrations. Calculate equilibrium concentration of carbon dioxide, hydrogen, carbon monoxide and H2O at 800 Kelvin. If only CO and H2O are present initially at concentration of 0.10 m each. 0.10 m each means concentration of carbon monoxide and H2O are equal. 0.10, 0.1 you can tell, 0.1 m, 0.1 m, 10 m, both are equal. Then see this question, it looks question is big, but it is very easy. Equation they have given, CO plus H2O, that is equal to CO2 plus H2. Then two reactants are there, two products are there. Then you have to calculate at equilibrium position, at equilibrium what is the concentration of all four. All four, what are the concentration? Means concentration of CO, concentration of H2O, concentration of CO2 and concentration of H2. You have to calculate all four. Means reactants and products both. Concentration at equilibrium you have to consider, you have to calculate. But here they have given Kc value they have given. Kc value they have given, and reaction taken place at 800 Kelvin. Actually in all the problems there is no role of temperature, because temperature is constant. Experiment was done on that temperature. That's why in question simply they are mentioning, because this is whatever question is there, experimental. Experiment was done. Okay, but there is you are not going to use temperature. Then how will you calculate now present question? What I told you, you have to calculate equilibrium constant of all four, means for reactants and for products. Then again it is very easy to calculate, but here you have to understand. Already you have written the reaction. Reaction means you have written CO plus H2O, that is equal to CO2 plus H2, all are gas. Then initially you have taken only reactant. Later on, after the reaction, you got the product. Initially you have taken two reactant, that is the carbon monoxide and H2O. Product was not there. Product formed after the reaction. Hence, in the beginning, carbon dioxide and H2 were 0, 0. Carbon dioxide was 0, H2 was 0 in the beginning. But in the beginning, reactant was there, carbon monoxide and H2O was there. And what was the concentration? Then 0.1 m, 0.1 m. Means carbon monoxide 0.1 m and H2 also 0.1 m. You should write like that way only. First you write the reaction, after that down you write initially 0.1 m, just below the carbon monoxide you write 0.1 m, and below the H2O you write 0.1 m, and below the CO2 you write 0, and below the H2 you write 0, because in the beginning product was not there. After that, now here you have to understand, you want to calculate molar concentration at equilibrium. Then you don't know what is the molar concentration. Then you just simply consider that, okay, X mole was there. X mole concentration was there. X mole, capital X or a small x, no problem. You consider that X mole per liter is the concentration at equilibrium. Just simply you consider the X, and finally you have to find the value of X. Okay, you have to find out what is the value of X. But now you consider that X is the concentration of you can say of the product, means CO2 and H2O. Okay, let X mole per liter of each of the product be formed. Just simply, because you don't know what is the product amount of moles of product formed, you don't know. You consider that simply you consider that, okay, after the reaction it will form you can say X mole of carbon dioxide and X mole of H2. Both will be equal. Why both will be equal? Because see, in a balanced equation, coefficient is nothing is written. It means 1. H2, CO2 coefficient nothing is written, means 1. H2 also coefficient is nothing is written, it's 1. It means both concentration will be the same. That's why you are considering X mole. X mole is the concentration of CO2 and H2. Then okay, product you have considered. Now then what will be the concentration of reactants at equilibrium? Then in the beginning it was both was 0.1. Then from that they reacted and they formed X mole. Then obviously when both will react, reactant will react, means carbon monoxide and H2O, when both will react, then their concentration will decrease. Then how much they will decrease? Then X mole they formed. Then now 0.1 minus X will remain. 0.1 minus X will remain of carbon monoxide, and same thing will remain for H2O, 0.1 minus X, that will remain. Correct? After the reaction, they will form X mole carbon dioxide and X mole H2. Then how much reactant will remain? Because X already used. Then 0.1 minus X will remain, and 0.1 minus X of CO will remain, and 0.1 minus X of H2O will remain. Means at equilibrium, this is the concentration. At equilibrium, this will be the concentration, 0.1 minus X, that is for carbon monoxide, again 0.1 minus X, that is for H2O, and X, that is for CO2 and H2. Then you have to find out, if you will come to know the value of X, then all four value will come to know. That at equilibrium, what was the value of all four? You will come to know. Then how will you come to know the X value? Then now again you have to just write the expression. Write the expression for Kc for this reaction. For this reaction, you have to write the expression for Kc. Then it is very easy. Kc is equal to, now you write, I can say concentration of products. First you have to write molar concentration of CO2 into molar concentration of H2 divided by molar concentration of CO into molar concentration of H2O. And now you put the value of concentration. Now you put the value of molar concentration of all. Then for CO2, X. For H2, again X. Then X into X divided by 1.1 minus X into 0.1 minus X, means 2 times. You can write 0.1 minus X square also. Then now you got the expression and you have put the value also, means Kc is equal to X into X square divided by 0.1 minus X, 2 times it was there, that's why you have written X square. Then Kc is equal to X square divided by 0.1 minus X power 2 X square. Then now you know how to solve this type of problem. Kc is equal to X square divided by 0.1 minus X power 2 X square. Then just you solve this Kc value is given. Kc value is given, that is the 4.24. Then 4.24 equal to X square divided by 0.1 minus X square. Then no quadratic equation you know. Then by the use of quadratic equation you can get the value of X. Then what is the quadratic equation? Actually after this equation, 4.24 that is equal to X square divided by 0.1 minus X square. If you will solve it, elaborate it, then you will get the expression that will be in the quadratic form, means X square minus Bx plus C. Ax square plus Bx plus C, that formula is there. Then you will get in that form. Okay, Ax square minus Bx plus C. It will come in this form. Then after that, formula I am telling you, that is quadratic equation. Ax square plus Bx plus C, that is equal to 0. That is the quadratic equation. Then you will get only in this form. After simplifying, you will get equation in this form only, in the form of Ax square plus Bx plus C is equal to 0. Then for this, how to solve this equation? You want to get the X value, then X is equal to, formula is there, minus b plus minus root under root b square minus 4ac divided by 2a. This is the formula you might be knowing. This is the formula for to get the value of x. When you have ax square plus bx plus c is equal to 0, then to get the x value, x is equal to minus b plus minus under root b square minus 4ac divided by 2a. Then if you will compare what you got the x after solving the expression, what you got, compare with this quadratic equation ax square plus bx plus c and put the value, find the value of a, b and c and put in the formula. Then you will get that is the 0.848, that is the value of b, okay, plus minus under root 0.848 power 2, because this is the square, b square, minus b was there and value is also in minus, then minus plus, then b value got 0.848 and plus minus under root 0.848 square minus 4ac, then 4 you have written, a value is 3.24 and c value is 0.0424, okay, divided by 2a, then a value is again a value is 3.24, okay, a value is 3.24 hence divided by 2a, then you can write 2 into 3.24, and after the solution, after the putting the value and solving it, you will get the value of x. You will get the value of x. Then x is equal to, you will get the value, how much you will get the value for x? Then you will get the value of 0.67 you will get, okay. You will get the value of 0.067 you will get the value, okay. Then how you got the value of x value you got. Then when you are getting the x value, it means you got the molar concentration of CO2 and H2, because you considered x mole then x mole is equal to, you got the value 0.067 m. Then what are the value of for reactants, two reactants CO and H2O? Then 0.1 minus x, again 0.1 minus x, then from the 0.1 m minus x, then x is equal to you got 0.67. Then what is the value of 0.1 minus 0.067? Then you will after deducting, you will get value these things 0.033 m you will get, 0.033 m you will get. Then you got same value you will get for the both reactant. Then like this way you can solve this type of numericals, and this type of numericals is asked in the examination. Okay, now I am stopping only here. Next class again we will meet. Thank you.